Alright guys, so this is continuing on with the last problem that we had, talking about the ballistic pendulum. So we said that a ballistic pendulum works by a bullet has some initial velocity, so I'm firing off a bullet, it has an initial velocity, it gets lodged in this second mass, which is just our piece of wood, and then ultimately the negligible mass strings, the wood is going to move up a specific height. So my goal is to figure out how can we determine the speed of the projectile based on h. So I can find the speed very easily of the bullet when it's with the mass of wood. And that's because we know that this is a perfectly inelastic collision and that velocity is found by final velocity equals the mass of the bullet times the initial velocity of the bullet divided by the mass of the bullet and the mass of the weight together. Now technically, like we said yesterday, this would be mb vb I plus the mass of the wood times the initial velocity of the wood, but right now my block is at rest, so that means that this entire thing would just be equal to 0. So that's why I'm not including that in that equation. So just to review that. Ultimately my goal, like we said, is to get initial velocity. So I want this, but I want it in terms of height. I want it in terms of h. Now, it's going to help us to also know how can I find the kinetic energy of this system with the bullet and the block moving together. And we derived that yesterday over here. So we know that kinetic energy is equal to the mass of the bullet squared times the initial velocity of the bullet squared over 2 times the masses of them added together. Okay, so again, I know all of this. I really want this, that's my goal, but I want it in terms of height. So I'm going to go to a new page here so we can kind of start from fresh. I don't know this initial velocity of the bullet, and I need it to be this equals something with height included. So I know a way I can get height into this equation would be by, I know kinetic energy, so I know a change in K. A way that I can get in height, change in potential energy. Because if kinetic energy is changing, potential energy must be changing as well. And since friction isn't acting on it, since I have no other external forces, I can call this an isolated system, so all of this should equal 0. And again, it's isolated because there's no friction working on it. It doesn't say anything else about other external forces acting on the bullet with the wood moving together, so that's why I can call it isolated. Ultimately, I know my change in K is just the final kinetic energy minus the initial, plus my change in U is that final potential energy minus initial, all of that equals 0. Okay, well if I'm thinking back to this block, let's go back. It's going to have some kinetic energy, it's going to have some speed initially because of that bullet entering into the wood. It's going to move up, and ultimately it's going to stop right when it gets up to that highest point at that height. And then it's going to stop and it's going to change direction. But I want to know what it would be just right here. So the final speed here would be 0 because it's gone to some height. So that means that if my final speed for this entire system is 0, then that means that my final kinetic energy is 0. I just found a formula for that initial kinetic energy. We found that, of the system, we found that earlier. And that's here. So I know that my initial kinetic energy of this system is going to be my mass of the bullet squared times the velocity of the initially of the bullet squared divided by 2 times the mass of both of them. So let's add that into where we have our initial kinetic energy. So that would be mass of the bullet squared times the initial velocity of the bullet squared over 2 times the masses combined. Okay, so then I can also think about potential energy. We know that potential energy is just mass, if we're thinking about it for gravity, because this would be gravitational, it's not elastic, we don't have a spring. So potential energy would be mass times acceleration due to gravity times the height. But I'm thinking about the system, so I'm thinking about the bullet with the block of wood. So technically, my system would have mass of the bullet plus the mass of the wood times G times H is what U is going to be. Now we know initially it's going to be given a certain speed. So if we're going back to this and we're looking at that picture, I know initially it has all kinetic energy once that bullet moves in and it's moving up. So initially, if this all has kinetic energy because of this bullet entering in, then its initial potential energy is just going to be 0. And then its final potential energy, when the speed is 0 up here, means I have no kinetic energy, so then my potential energy here would be the mass times the acceleration due to gravity times height. So my final, let's kind of keep these together, my final one would be mass of the bullet plus the mass of the weight times G times H, and then minus the initial, which would just be 0. And all of that is equal to 0. So ultimately, our goal, we have everything that we need. We just have to rearrange this entire thing to solve for the initial velocity of the bullet. So if I do that, let's add this huge term over here, because then that will make that positive. So then I would be, and let's actually make this smaller. Okay, so I would have the mass of the bullet plus the mass of the wood times acceleration due to gravity times height. That's going to equal the mass of the bullet squared times the velocity of, the initial velocity of the bullet squared over 2 times the mass of the bullet plus the mass of the wood. Okay, I want to solve for this. So let's multiply both sides by mass of the bullet. 2 times mass of the bullet plus mass of the wood. If I do that, then this becomes, I'll have this times another one of these times 2, so isn't that just squared times 2? So now I'm going to get rid of this. Okay, now my goal, again, I just want this by itself. So let's divide both sides by the mass of the bullet. So mass of the bullet, and that's squared. So now those cancel. So now I'm left with the initial velocity of the bullet squared, but let's see, I know I need to square root this. So if I square root this, and overall I square root this. Okay, well the mass of the bullet plus the mass of the wood together is already squared. So if I'm square rooting a square, I'm going to kick that out, so it's just going to be mass of the bullet plus the mass of the weight. And then the mass of the bullet down here in the denominator is also squared. So this is going to become also kicked out of that square root. So I just have mass of the bullet. So I'm going to end up multiplying that by what's left under my square root, 2gh. So that's all times the square root of 2gh. And that equals your initial velocity of the bullet. Guys, this would be a fantastic free response question. So ultimately we used energy methods. We also were using some of our collision stuff here for chapter 9. So it's kind of getting a lot of things in together. If you have questions on this, if you're wondering just any step that I kind of maybe went through a little quickly, post on the blog. If not, then I'm going to post, I want you to try 2 problems that are already in your PowerPoint on your own. I'll tell you which problems on your blog because I'm not sure which slide numbers they are. But then, again, for your lab, if you did not finish with the data analysis part with Logger Pro, then I'd like you to make sure that you come in between now and next Wednesday when it's due to come in and finish it up. And I think we're good. Have a great day. Bye.